So welcome everyone to our monthly Lunch and Learn webinar. Everyone should be muted as you join, and I'm asking you to stay on mute until the end when we can open it up for questions. This session is being recorded, and the link to the recording and the slide presentation will be shared with everyone who signed up for the webinar and all of the NEBR membership as well next week. Also, there's a Q&A function at the bottom and a chat function. I'll be keeping an eye on those during the webinar, but please feel free to enter questions and comments as you think of them. It makes my job easier. So today's webinar, we're going to hear from a company called InnoWaste about their patented process for municipal and industrial sludge processing applications. Sometimes we like to use these webinars, especially since PFAS, to vet emerging technologies for solids handling. And I'm sure a lot of you have come hoping this could be the game changer. And I know I'm rooting for all the solutions that we can get. And I think you will think this InnoPellet concept is elegant. So let's get to it. Presenting today from Budapest, Hungary, is István Veresky, the managing director for InnoWaste. His company has developed this InnoPellet system that you're going to hear about. István is an economist with a degree from Budapest University of Applied Sciences, and joining him today and supporting InnoWaste in breaking into the North American markets are Rick Wire and Fred Rogers. Fred is the VP of Marketing for InnoWaste, focusing on building the U.S. market. He's currently a mentor for the CleanTech Open Invent Pen, the National Science Foundation's National I-Corps program. And Rick is an engineer by background with an undergraduate degree in aerospace engineering from Virginia Tech, a master's in oceanography engineering from the University of Rhode Island. And he has an MBA from Penn State, where he was an instructor in entrepreneurship before branching out on his own to help companies like InnoWaste. And Rick is the one that makes the actual introduction here. And I'm very happy to introduce István to present on his process of InnoPellets. Take it away if you want to grab that screen share.
Okay, nice to meet you. I'm István Veresky from Budapest, from InnoWaste. I'm the managing director of InnoWaste, and thank you very much for the opportunity to present our technology. And I will share the screen now. All right, so InnoWaste is a renewable energy company providing a state-of-the-art solution for turning urban wastewater sludge into solid recovered fuel and giving a cost advantage for small and medium-sized wastewater treatment plants. I think you might have a good understanding of situation of utilizing urban wastewater sludge. So there are a couple of solutions now applied: landfilling, land spreading, and burning with incineration with supporting burners. But all of them have a really serious barrier: the high water content of sludge. That's always an issue. So from one point, there are stricter and stricter regulations are coming up. Especially for landfilling and land spreading and all land applications. And as most of the time, sludge has a water content of 70 to 80%, the mechanically water sludge, I mean. So it is generating high transport costs, tipping fees, and at the moment there is no centralized solution for using the sludge on site beneficially, or on small and medium-sized treatment plants. So more than 40,000 wastewater treatment plants in this size are facing a very similar problem in the US and also in Europe as well. And we are not just processing urban wastewater sludge, but our technology is also applicable for slaughterhouses, slaughterhouse sludges, and agricultural sludges due to its high heating value. So what we're doing is turning this the manically dewatered sludge in a two steps drying procedure into solid recovered fuel. So we are not burning waste in the end. This is a classified fuel, and we do have a mono incineration procedure. And during this procedure, we are generating a really valuable ash with high potassium and phosphorus content, which is favorable for the fertilizer industry. And it fits perfectly to the circular economy. We have a low capex and opex during this procedure with a low land demand, and we comply with the EU and EPA regulations as well. And we do have certifications for our machine. TUV, it's EPA equivalent certification for the machine, and TUV for the end product pellet as well. So what we are doing is picking up the sludge either from 1%, applying a screw press, or receiving it directly from the centrifuge with approximately 20-25% dry solid. Obviously, we need a certain electricity load, 28 kilowatt hours for the continuous operation. We only need electricity for moving the conveyors, the fence, but we don't need electricity for generating heat to dry the sludge with. So what we are using our own end product, and in a two-step system, we are drying the sludge. While we have an output of flue gas, which is really far below the limit values, approximately 1/3. At urban wastewater sludge, approximately 16% of the remaining ash is phosphorus, so it's been taken away immediately by fertilizer companies. And the end product is a solid recovery fuel. So let's get to the material flow. So as I mentioned, we can pick up the sludge from 1-2% or 2-8% applying a screw press, or directly from the centrifuge. The thermal procedure starts from 20% dry solid. So we have a pre and a main dryer where we dry the sludge in 2 steps and reach 30-50 and then 85-95% dry solid content in the end. By using our own end product pellets, it's originated from primary sludge. At this case, we have a 60-80% of the output should be reused for generating heat. The rest could be commercialized or even used on site for heat generation. And also there is a high demand on the remaining gas. So let's just have an example. The capacity of our unit is 11 wet tons with 20% dry solid content sludge. This is when wet ton, I mean metric tons. We need we need electricity, obviously, for moving the sludge in the subunits. But we use our own end product pellet to generate the heat we are drying the sludge with. We have a 770-940 Celsius degree temperature in the mono incineration unit. In this case, it might be useful for PFAS destruction. In the pre and main dryer, we have 100-160 Celsius degree, where the sludge is being dried in within 2 times 44 minutes. and it's reaching 90% dry solid content. So the leftover pellets could be used for heat generation, as I mentioned. That's a considerable heat load which could be used on site if there is a need for that. So basically, our main advantage is that we are, as if we're using applying the screw press, then we are completely eliminating the local logistics. So no storage facility, no dump trucks are required. We're just picking up the sludge from the clarifier directly, and we process it. And there are no further steps. If there is already a screw, if there is already a centrifuge in operation, for example, then we can pick it up from 20%, but in this case, we need a storage tank. So we have a fairly small footprint. It's 2,400, 2,500 square feet, which is so the processing of a sludge of 50,000 people equivalent fits to the size of a house. So that's quite favorable. We have one unit in operation in Hungary, and now we are about to sign a contract now for 4 units for big size slaughterhouse, and also with Veolia in Slovakia for 2 units. So as I mentioned, the footprint itself is fairly small, considering processing the sludge of 11 cubic meters in a 24-hour operation. And let's have a short video of it just to imagine. So this is a regular 3 cubic meter container pouring the sludge into the storage tank. A screw conveyor is pulling in the mechanically dewatered sludge with approximately 20% dry solid, and this is the end product, which looks like brown coal, and it has a heating value like brown coal, 7,300 to 8,000 BTUs. I know the European equivalent, 17 to 18.5 megajoule per kilograms, so it's relatively high. So we have another advantage. We have one product and this is our size, this 50,000 people equivalent. But the question is raised often that if it's possible to be upscaled, and my answer is obviously yes, and more units could be placed next to each other. It also gives the wastewater utilities a certain flexibility, because if, for example, 8 units are in operation and 1 is in maintenance, then 7 would still keep functioning. So the continuous sludge processing is obviously maintainable. So we have to currently big clients. We are working 2 big projects. One is in the UAE for 55 units placed next to each other on the left-hand side, and on the right-hand side for the Cairo municipality in Egypt for 36 units placed next to each other. Sometimes they do have a limitation with the space, and in this case, our solution is obviously the best on the market at the moment. So we have a modular structure of the pre and main dryer. These are identical twins, which gives us the opportunity. It consists of 3 layers. And if there is any more function with 1 layer, then we just change it, and we fix it not on site, but at our facilities. So it's possible to put back the unit into production within a couple of hours, and that's also a big advantage. So we don't have to stop for a couple of days. There's a comparison. Obviously, we are not the only ones providing a thermal solution or drying the sludge, but we are the only ones using our own end product. And comparing to Hubelt's belt dryer, which is using natural gas or the waste heat of power plants, obviously their operation costs will be much higher. And there are solar systems as well. They are quite popular in Europe, and they have I have seen several projects in the US for solar as well. But that's the main disadvantage is that it requires um, 5 to 6 times more space than ours. And as the sludge has to be moved physically, it obviously has a much higher electricity cost. So there is a comparison with landfilling and incineration, and we have, well, between the return on investment of each unit is between 2 to 6 years. Here, these cases, 3.5 and 3 years. And we've been working together with the University of Illinois, also for double checking our numbers, and also working on case studies, comparing with other solutions. And here is we also had a project with the University of Illinois, where we were comparing the greenhouse gas emissions of InnoPellet and landfilling, and we have a 55% lower greenhouse gas emissions, as the uncontrolled during the landfilling, a certain amount of methane is being emitted, and this could be avoided by drying and incinerating the sludge on site immediately. So that gives the advantage. We have a patent granted in over 30 countries, also in the United States. So, and in all the Western Europe and European countries, even in Russia, but it's not that useful at the moment. But our machine and procedure is patented. That was a long process, over 10 years. So summarizing the features and benefits, so we have a certification, a TÜV certification, which is equivalent to UL. We have a major advantage compared to incineration and landfilling, also at CapEx and OpEx. We have a low power demand and small size of units. It's easy to be, it fits easily on site. I haven't really seen any wastewater treatment plant which does not have a land of 2,400 square feet, so it could be easily placed on site. And we can avoid tipping fees and trucking transport costs completely, with the unit having a return on investment of 2 to 6 years. And these units are automated, so remote and continuous monitoring is provided. So we have a major cost decreaser, a cost advantage for the treatment plants, a quick payback time. We do not apply any fossil fuels, any additional supporting burners. We have much lower footprint and several certifications which could be also applied in the US. And thank you very much for your attention. And if you have any questions, then feel free to ask.
Yes, we already have one question, and I have a couple of questions too.
All right.
But one of our members is asking, would the InnoPellet system work on digested sludge or only
Uh,
undigested sludge?
uh, Basically, we're using primary sludge. It has a heating value. I'm telling it the European metrics 18 and a half megajoule per kilograms. Digested sludge has a lower heating value, but till 13 megajoule per kilogram. So it can be between 11 and 13 megajoule per kilograms, but the whole procedure could be maintained or self-propelled till 13 megajoule per kilogram. So if we're not going below 13, then we have enough heating value to make it self-sufficiently. So at that case, burning all the pellets for generating the heat. If we are going below 13 megajoule per kilograms, we need additional heat, but that's still more favorable. We have now 3 tenders in India. They have anaerobic digesters, but they still have the problem with the sludge. So they're willing to do something with that. And then in the end, they were turning to us to solve this issue. So yes, my answer is it's possible, but with certain restrictions. Depends on the heating value.
And I heard you stress primary sludge. So it's really just for primary sludges, not mixed secondary waste
The,
sludges.
the mixed has a heating value usually of 15 megajoule per kilogram, so it's doable. So that
Okay.
works.
Yeah, similar to your answer for anaerobic digestion. Although it dilutes
Uh,
the BTU value, you can
Yes,
still
yes,
manage it.
yes, yeah, yeah.
Yeah.
Right. So the mix is okay.
All right. If anyone wants to just raise their hand, feel free to do that, and we can answer your questions. So Ishvan, could you explain a little bit more about the process? Is it a batch or a continuous batch process? I was trying to figure out how that works. And how long is, you mentioned 45 minutes. So that's why
Uh,
I was like, oh, maybe this is a batch process.
44, 2 times 44 minutes. And it's a continuous material flow.
Okay. Okay.
The sludge is being spread on the upper level of the by extruders on the upper level of the pre-dryer and the main dryer. It goes continuously, and it goes from the pre-dryer to the main dryer with another screw conveyor, and then it's being re-extruded. And that's a key component in drying the sludge, because what was outside gets inside, so the drying of the sludge gets way more efficient this way. So it's been re-extruded 2 times the procedure, and we have a continuous material flow. We have an 85-95% solid content end product, and that end product we're using in the incinerator. 60 to 80% depending on heating value, ambient temperature, humidity. So there are several factors affecting the ratio of pellet should be used. But basically, originated from primary sludge, we have an experience of 60 to 80% should be fueled back. So, and this is a continuous procedure. It's not, as you mentioned, batch. But the incineration itself has a high oxygen level, so it's a non-conventional burning procedure. We have a high oxygen level, and we do not apply pressure in the system. That's important as well. And we use air-to-air heat exchange, an air-to-air heat exchanger system to generate the heat we are drying the sludge with. So that's another key feature of the technology.
Trying to use all of the waste heat you can in the system.
Absolutely
Yeah.
correct.
Yeah, that's That's great. I don't know if there's any other questions here. I think you guys might have had some questions for us, maybe. And earlier when we were chatting before, you were mentioning about a live stream event where we might be able to see
Uh,
this thing operating in
Rick, do you want
Hungary.
to take that?
Well, I'll let Isran fill in the blanks if I get this wrong, but we are planning to have some potential customers come and view the operation of the device in Hungary. And sometime around, I think, September the 18th, is when those visitors may show up. Isran has the ability to potentially live stream that visit, so that if you really wanted to see this device in action and actually see what it does and how it works and operates, this would be an opportunity to do so. And one thing we wanted to ask of the audience today, that if you're interested in that, please indicate that to Janine, and we'll be in touch with her to hear, how many of you might be willing to participate in that, and we'll arrange a way for you to be able to view that. Because it's a comment we've gotten as we've gone around and talked to a lot of wastewater plant operators is, hey, this sounds really interesting. We love the concept, but how do we see it work and operate, right? And as of yet, we have not established a presence in the U.S. We hope to do that in the U.S. market. And that transitions me right to my second question to the audience today would be, if anybody out there is in a position or is aware of anyone who might be able to work with us to establish a pilot in the United States, we're extremely interested in that, where we would potentially be able to come in, set up a facility on your property, work to process some of the sludge, see how it works for your particular municipality. A lot of details there would have to be worked out, but one thing we are really seeking is an opportunity to get a facility built and established in the U.S. so that U.S. operators would have a chance to be able to talk to another operator, come visit, see the device and work. And we understand that, there's words mean one thing. Seeing it with your eyeballs and watching it work means something entirely different. And so if anyone is interested in something like that, or knows of someone who you could connect us to who might be able to do something like that, again, please pass that information back via Janine, and we would love to hear from you about that.
Yeah, I can include it in the follow-up email.
I'll add to that, and to Janine's point, the University of Illinois is prepared, if we had a system operating in the US, is prepared to do a study on the flue gas emissions for PFAS.
Right.
So we are in a position where we could actually test the air production of PFAS with the University of Illinois, which would then get categorical information as to whether we destroy PFAS or not. We think we do, because back to your point, Janine, the temperature is high enough that the literature tells us that the PFAS would be destroyed. But until we actually test it coming out of our flue gas, we won't know. But the University of Illinois is prepared to do that with us. So,
yeah, so I can, when I send out the follow-up email, I can make those couple of asks, and maybe folks won't be so shy responding to my email as opposed to raising their hands today, but that's okay.
Yeah.
We have another question, one of our engineering members. Are the emissions from the facility subject to EPA's sewer sludge incineration rules? And what kind of emission controls are there?
Yes, we meet the emissions. So, but one thing I must underline: we're not burning sludge. We're burning a solid recovered fuel originated from sludge. So basically, this is not waste burning. We have a certificate for this end product, so it's a non-infectious burning material which could be used. And the University of Illinois made the background check, and according to the current regulations, it could be used. Our system could be used in the state of Illinois, and as far as we know, in approximately 30 states for sure, without any. We're not. We're meeting the flue gas limit values, but it has to be checked state by state, because there might be differences.
But we're below the
Yeah.
EPA standards. We
We,
may
we
not
are
be
below,
below,
yes, yes,
we're below the EPA standards. And
that's
again,
correct.
the University of Illinois has tested that, and we've got a chart that we could provide that identifies the flue gas emissions done by the
Yeah, I'm
university.
sure the engineers would love that if you want to
Yeah.
send that along with the slide deck too.
Yeah, sure.
Okay.
Because they'll certainly help you to get these things somewhere in an operating treatment facility here, so.
Yeah.
I think you might have more interest than maybe you might have had in the past, so I think we'll see. Any other questions, folks? You can just raise your hand if you want to stump the presenters. Yeah, no, this is a very interesting concept, this whole self-contained burning your own pellets.
I want to reemphasize what Ishvan just said. We're not incinerating
Right.
waste. We're incinerating a fuel which is certified by the EPA as a legitimate fuel equivalent to coal, only it's environmentally friendly. So
All right, anyone else with any questions? I may have some questions after I send out the email next week, so we can certainly keep in touch, you guys.
Very good.
we
And
thank you so much.
Yeah,
Yeah.
yeah. No, really, seriously, rooting for you. It's a really cool concept, and if you can get it operating somewhere here, they will come.
All right. Thank you,
So
Janine. Thank you to
yeah,
the
thanks you
audience.
guys.
Thanks.
Rick and Fred,
All right.
Ishvan. Thanks everybody
All
for
right.
spending your Friday with us
Yes.
and joining us today. Next month, we're going to lunch and learn about sewage sludge incineration, actually. And it's an important leg of the stool around here for sure. I've invited a panel of experts, and we're going to cover beneficial end uses and, of course, the potential to destroy PFAS, because that's the big topic. So as always, if there's something you want to lunch and learn about, please shoot me an email. I'm always looking for suggestions. Have a great day, everyone. Happy Friday, and enjoy your weekend.
Thank
Thanks
you,
a lot.
everyone.
Yes.
Thanks again, guys.
Thank
Uh-huh.
you. Have a nice weekend.
Bye.
Bye.
Take care.
Bye.